Theorems on Similarity of Triangles. Quarter 3, MELC 11. At the end of this lesson, you are expected to apply the theorems to show that given triangles are similar. What are similar triangles? Similar triangles are triangles with the same shape but different side measurements. In other words, two triangles are similar if all their angles are equal and corresponding sides are in the same ratio. SSS Similarity Theorem. If two triangles have three pairs of sides in the same ratio, then the triangles are similar. In this example, the ratios of sides are BC is to XY. So in triangle ABC, side BC is here. It has a measure of 8. And in triangle XYZ, side XY is here. It has a measure of 10. So the ratio is 8 is to 10. Simplify by using the greatest common factor. The GCF of 8 and 10 is 2. So divide 8 by 2, that is 4. 10 divided by 2 is 5. So the simplest form of the ratio is 4 is to 5. Next, AC is to ZY. AC is 16, ZY is 20. So 16 is to 20, simplify. That is also 4 is to 5. Next pair of side is AB is to XZ. So the measure of AB is 4, XZ is 5. So the ratio is 4 is to 5. These ratios are equal, so the two triangles are similar. Next is the SAS Similarity Theorem. S refers to side, A refers to angle, and S refers to side. So that is side, angle, side similarity theorem. If two triangles have two pairs of sides in the same ratio and the included angles are also equal, then the triangles are similar. In this example, we can see that one pair of sides is in the ratio of 21 is to 14. So this side BA is paired with side XY. So the ratio is 21 is to 14. Simplify. That is 3 is to 2. Another pair of sides is in the ratio of 15 is to 10. So that is side CA and side ZX. The simplest form of 15 is to 10 is 3 is to 2. Then, there is a matching angle of 40 degrees in between them. So, between side BA and side CA, there is angle A. So, this is the included angle in triangle ABC. And in triangle XYZ, the included angle is 40 degrees. So, that is side, angle, side. So there is enough information to tell us that the two triangles are similar. Exercise. Direction. Complete the table below to show that the given triangles are similar. So in here, you have to write the side, which is the hypotenuse, the side, which is the longer leg, and the side, which is the shorter leg. And in the row of ratio, so you indicate or you write the measure of the indicated side. So you have 5 minutes to answer this exercise. Okay, let us check your work. In triangle ABC, the hypotenuse is side AB. Remember that the hypotenuse is the opposite side of the right angle. So the right angle here is angle C. Next, the longer leg, so that is side CA. And the shorter leg is side BC. Next, in triangle XYZ, the hypotenuse is side XY, the longer leg is side XZ, and the shorter leg is side YZ. Next, in the ratio, AB is to XY. AB is 15, XY is 9. So 15 is to 9. Simplify, that is 5 is to 3. Next, AC is 10. XZ is 6. 10 is to 6, so that is 5 is to 3. Next, in the shorter leg, BC is to YZ. So that is 5 is to 3. So as we can see, the ratios are equal. It means that the given two triangles are similar. The Pythagorean theorem and its proof. Quarter 3, MELC 12. At the end of this lesson, you are expected to prove the Pythagorean theorem. What is a Pythagorean theorem? The Pythagorean theorem is considered as one of the best known and most useful theorems in mathematics. It is attributed to the Greek mathematician and philosopher Pythagoras and his followers who proved this theorem about 2,500 years ago. The Pythagorean theorem is the square of the hypotenuse of a right triangle is equal to the sum of the squares of the legs. That is, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse of the right triangle. So we have here triangle LMN. The right angle is angle M. So given LM equals R. So gagamit tayo ng variable na small letter r, s, and t. So side LM is equal to r and mn is equal to s as the legs. Ln equals t as the hypotenuse. Angle LMN is a right angle. So we need to prove that r squared plus s squared equals t squared. So here is the proof. Construct altitude mk equals w to the hypotenuse. Ln equals t. Dividing it to lk equals u and kn equals v. So the original triangle is here, triangle LMN. Then, we drawn an altitude to the hypotenuse. So, altitude is a segment perpendicular to the other side. When we say perpendicular, right angle is formed. So, MK is small letter W. And then, yung side na T, small letter T, ay naging dalawa yung segment. Mayroong U at saka V. So, we have now three triangles. Describe triangles LMN, MKN, and LKM when an altitude MK is drawn to its hypotenuse. So, we can say that the three triangles are similar. So, take note of this symbol. It means this symbol is similar. The reason is right triangle similarity theorem. Next, number 2. Write the proportions involving the geometric mean R and S. So, we have U over R equals R over T. So, our geometric mean here is R. U is this. This is the shorter leg of triangle LMK. R is the hypotenuse. Then, this R is the leg of the original triangle. And then T is the hypotenuse. So the ratio is shorter leg over the hypotenuse of the two triangles. Another proportion written is V over S. So V is here. This is the longer leg of triangle MKN. And S is the hypotenuse. V over S equals S over T. So S, in the other way, is the longer leg of the original triangle LMN. And T is its hypotenuse. So the ratio here is longer leg over the hypotenuse of the triangle formed versus the original triangle. So the reason is special properties of right triangles. Next, cross-multiply the terms of the proportions in statement number 2. So that is S squared equals VT. Reason, cross-multiplication property of proportions. Number 4, add S squared to both sides of R squared equals UT in statement 3. So that is R squared plus S squared equals UT plus S squared. Reason, addition property of equality. Number 5, substitute S squared on the right side of statement 4 using its equivalent from statement 3. So that is R squared plus S squared equals UT plus VT. So from statement 3, S squared equals VT. So just substitute VT in the position of S squared. Kaya naging UT plus VT. So the reason is substitution property of equality. Next, factor the right side of statement 5. So the right side will become T times the quantity of U plus V. So the reason is common monomial factoring. Next, substitute U plus V in statement 6 by its equivalent length in the figure. So U plus V is equal to T. So this will become R squared plus S squared equals T times T. So that is segment addition postulate. Next, simplify the right side of statement 7. So T times T is T squared. So it will become R squared plus S squared equals T squared. That is the product law of exponents. Okay, I hope that you understood my explanation. So let's do this exercise. Use the Pythagorean theorem to find the unknown side of the given right triangle if two of its sides are given.